Okay, today we're going to be talking about rate of change and slope. This is actually the first section in Unit 2, but we are tacking it on to the end of Unit 1. It works quite nicely with what we just did. We talked about rate of change, so now we're going to extend that to rate of change's relation to slope. If two measures are related, the rate of change between them could be called a slope when you're talking about graphing that relationship. The formula for calculating the slope of a line segment that goes through 2 points is, in informal terms, the rise over the run, or the change in y over the change in x. Delta is equal to a Greek letter and means the change in. If we want to know how much something changed, for instance, your height, if you grew 3 inches, that might be indicated by your height at 2 different points. If you were 5 foot 2 inches, and then later you measured yourself and you were 5 foot 5 inches tall, then if we subtract those 2 measures, we get the change in your height, which is 3 inches. The same thing is occurring here. Whenever we find the change in something, we're going to subtract. So the change in y over the change in x is y2 minus y1 over x2 minus x1. So if I look at segment AB to the right, segment AB has a delta y of 2 and a delta x of 5, if we count those squares. That means as I go from point A to point B, I go right 5 and up 2. Or I can go up 2 and right 5 and still get to the same place. Either order works. All right, for segment CD, our deltas are a little bit different. Our delta y is, I would say, a negative number, and it looks like it's headed downward 4 units, and our delta x is a positive number. We're headed rightward 2 units. So we can think of it as directional. If I'm traveling from C to D, I go down 4 and right 2. Or I can go right 2 and down 4. So segment AB has a slope of 2 over 5. That's the rise for that segment over the run for that segment. Segment CD has a slope of negative 4 over 2. That's the rise for that segment, and the rise is actually more like a fall over the run for that segment. The slope for segment CD simplifies to negative 2. All right, we are going to classify each rate of change as positive, negative, 0, or undefined. So, for instance, in part A, let's think about rise and run. For A, between 2 points, our delta y is what kind of number? 0. There is no rise. We don't change vertically as we go from one point to the next. Our delta x is some number. So that means that our slope is 0 over some number. If you remember, 0 divided by any number is 0. So that means that our slope is 0 for that graph. For the next graph, I'm going to pick 2 points and I'm going to travel from one to the next. I'm not as interested in what the actual numerical value is for the rise, but more, is it headed upward? Yes. So delta y is positive. Delta x, which is the run as we go from one point to the next, is also positive because we are headed to the right. So if we're headed to the right and up, both delta x and delta y are positive. So that means that our slope is a positive number over a positive number, which equals a positive number. In C, if I pick 2 points and head from one to the next, our delta y is this time a negative number, because as we head from one point to the next, we fall or head downward. Downward indicates negative. Delta x is a positive number because we're headed to the right. So that means that our slope is a negative number over a positive number, which is a negative number. So for part C, the slope is negative. And then for part D, as we head from one point to another, our delta y is a negative number. Our delta x is 0 because we're headed neither to the left nor to the right. And so that means that our slope is a negative number over 0. And that is undefined because we can't divide by 0. All right, so I want to find the slope of the line through the point 5, 2 and the point 7, 8. So I'm going to graph those points really quickly. Over 5 and up 2, and over 7 and up 8. So what I want to do is to find the slope of the line segment that contains those 2 points, or the line that contains those 2 points. So I'm going to use my slope formula. Slope is equal to y2 minus y1 over x2 minus x1. So I'll pick the 2 y values to subtract on the top. I like to draw 2 little arrows toward them so that I remember to use both of the y values. And then on the bottom of the fraction, I'm going to subtract the x values. So let me indicate those in a different color. I'm going to subtract 7 minus 5. Now what I want you to notice is that we have to do this subtraction in a very careful order. Notice that I called 8 y1. That means that I have to call 7 I called 8 y2. That means that I have to call 7 x2. I called 2 the value for y1. That means that I have to call 5 the value for x1. The subscripts indicate which point they came from. So we can think of this one as the first point, and then we can think of the other one as the second point. It doesn't make any difference which one you choose to be the first point and which one you choose to be the second point. You can try this and you should still get the same result regardless. All right, let's finish our calculation for the slope. 8 minus 2 is 6. 7 minus 5 is 2. And so that fraction reduces to 3, a whole number 3. Now we can think of 3 as 3 over 1. And 3 indicates our rise, and 1 indicates our run. So I'm going to put this in a thought bubble here. And let's look at our points that we graphed. That means that as I go from one point to the next, I can do so by rising 3 and running 1. That means I go up 3 and right 1. And then I can do that one more time, up 3 and right 1 to get to the second point. So our slope matches what we see in the graph. All right, for example 3, we're going to find the slope of a line through -1, 3 and -5, 7. Our slope formula is m is equal to y2 minus y1 over x2 minus x1. So it doesn't matter which one you pick, but I'm going to call the first point that's listed the first point. That is to say x1, comma, y1. And I'm going to call the second point the second point. That is to say x2, comma, y2. So when we subtract the y's on top, be very careful that you subtract just the y values. So I'm going to circle them. And so subtracting them, the second one minus the first one would give us 7 minus 3. Now subtracting the x values, the second one minus the first one would give us -5 minus -1. Be very careful with subtracting negatives. All right, let's finish this calculation. 7 minus 3 is 4. -5 minus -1 is the same thing as 7 minus 3 over -5 plus 1. So our denominator is -5 plus 1, or -4, and that means that our slope is -1. Let's check this by graphing the 2 points. The point -1, 3 is 1 left and 3 up. The point -5, 7 is 5 to the left and 7 up. If I graph those 2 points and connect them, what you'll notice is to get from one point to the next, I can fall one and move right one, fall one and move right one, etc. So our slope computation matches what we see in the graph. In example 4, we need to find the slope of the line through 1, -2 and 6, -2. So that we are going to use our slope formula. Slope is equal to y2 minus y1 over x2 minus x1. So the first thing that I'll do is to subtract the y's on the top. So that would be -2 minus itself, -2. And then we'll subtract the x's on the bottom, 6 minus 1. -2 minus -2 is the same thing as -2 plus 2. So then that's going to give us 0 over 5. 0 divided by any number other than 0 is 5. Let's graph our 2 points and see that that matches up. Wow, I'm very tired because I just said 0 divided by 5 is 5. That is not true. 0 divided by 5 is 0. All right, so let's graph our points and see if that matches up. 1, -2 and 6, -2. What we see is a line that contains those 2 points where there is a 0 rise and a positive run if we go from one point to the next. All right, let's find one more slope. Find the slope of the line through 3, -4 and 3, 5. Again, we're going to use our slope formula. M, the slope, is equal to 5 minus -4 over 3 minus 3. 5 minus -4 is 5 plus 4. 3 minus 3 is 0. So we have 9 divided by 0. Any number divided by 0 is undefined. So that means that our slope is undefined. Let's graph our 2 points and see that that matches up. 3, -4 is 3 units over and 4 down. 3, 5 is 3 units over and 5 up. You notice that if we connect those 2 points, that there is no run. The run is equal to 0. And that's what happened with our denominator. So the slope of that is undefined. All right, now we're going to find 2 points on the line that um, that work in this equation. So in order to do that, we can just pick an x value. I'm going to create a table of values here, and I'm going to pick an x value. One of my favorite x values to work with is 0. To get the y value, we're going to plug in 0 to this equation. So y is equal to negative 1/3 times 0 plus 2. Doing the computations, negative 1/3 times 0 is 0, plus 2 is 2. Now I'm going to need to pick a second point, so I'm going to pick an x value, and I might pick 3 this time. Now why don't I pick 1 or 2? What I want to do is to pick a number that is going to be easy to multiply by negative 1/3. So 3 being a multiple of 3 makes that a fairly easy calculation. So y is equal to negative 1/3 times 3 plus 2. Doing the computations, negative 1/3 times 3 is negative 1. Negative 1 plus 2 is 1. So now let's calculate our slope. M is equal to y2 minus y1 over x2 minus x1. That's equal to 2 minus 1 over 0 minus 3. That's going to give us 1 over negative 3. A positive divided by a negative is a negative, so our slope is negative 1/3. All right, let's create a table for the equation in part B. I'm going to choose an x value to plug into the equation and to see what that makes the y value. I'm going to choose my favorite number, 0, again. And if you look at the equation, if I plug in 0, wait a minute, there's nowhere to plug in 0. So does it matter that x is equal to 0? That's right, it doesn't. So if it doesn't matter, what should y be? Our equation is telling us what y should be, correct? Our equation tells us that y is 4. So if I plug in another value of x, and I'm guessing it doesn't really matter which one I choose. Let me just choose 2, for instance. You can choose whatever value you want. I guess it doesn't matter that x is 2. My equation still tells me that y has to be 4. So when we calculate our slope, m is equal to y2 minus y1 over x2 minus x1, which is 4 minus 4 over 0 minus 2. 4 minus 4 is 0. 0 minus 2 is negative 2. 0 divided by any number that's not 0 is 0. So our slope is 0. The rest of the lesson will be in the next video.